Welcome everyone, this is part 3. Today we'll actually write some functions and we'll write functionality for our hand to understand if it's a left hand or a right hand. And again, I'll be explaining all the logic behind my thinking, why we're doing this, so you can understand everything, even if you don't know C++. What I did, I created a folder called blueprints and I created character and hands. On last lecture, we created our blueprint for left hand, so let's go ahead and duplicate it and call it BP right hand. And that's the beauty of creating our class once and just duplicating, calling this left hand, this right hand. And let's go ahead in our C++ classes and create a blueprint for our character. So let's go to our characters, right click on C++ and create blueprint class. I will put it in my character folder I created right here, and I'm going to call it BP VR character, and I'm going to put it right here. It will open a blueprint, but we do not need it right now. So let's close it. Now let's dive into our C++. Now our hand doesn't know whether it's left or right. So we need some kind of way to let our hand know what hand it is, right? Let's see how Unreal Engine does it. If we look for our grab component, it has function getHeldByHand. So basically this function in grab component identifies which hand grabs object. Let's see how it does it. It basically has a motion controller, gets its motion source, check if it's left or right, and has some weird green thingy. And this is enumeration. Let's see what type is it. It's eController hand. So what we know right now, that Unreal Engine has some specific variable to know which hand it is. And that's exactly how we can identify our hand. We can create a variable of type eController hand. You can see it's written right here in our hand, and just set it in our hand before we spawn it in the level, so we could identify which hand it is, right? So let's go to our C++ and look for this variable, what it is. How we can find this variable? Our motion controller should have this variable, right? So if we control and left click on our motion controller and look for eController hand, we can see that there are some variables like that. And to see what is eController hand, we can again control left click and see where it's defined. So this is where it's defined. You can compare the values. You can see that they're the same. Left, right, any hand pad, left, right, any hand pad. Before we actually use it, I want to explain what it is, right? Because we want to understand what we are working with. I'll open Paint, and what we can see, we have enum class eController hand, that's the name, and we see that it's based on uint8. What it means? U means unsigned. It's based on positive numbers, and there is this 8 in the end. What 8 means? That it takes only 8 bits. What is a bit? I told you in a previous lecture that each memory consists of cells, and those cells have values of 1 or 0. That's how machines understand what you're writing. So here I drew 8 bits. So we have 8 bits here, which is the same as 1 byte. So each of those bits can have a value of 0 and 1. So either 0 or 1. Meaning that if we have those 8 cells, each cell can have 2 combinations, resulting in 2 to the power of 8 combinations, which equals to 256. What it means, that if you base your enumeration on an unsigned integer that takes 8 bits, you can at most create 256 variations, meaning that our enumeration can hold up 256 values. And each of those values is mapped to a number, 0, 1, 2, 3. How can we verify it? In our enumeration right here, there is another way we can compare enumerations. And we can compare them by equal operator, and we can see here we can compare by number. Our C++ sees it as 0, 1, 2, 3. But if we are programmers, we need to understand what those values are, therefore we mark them as words. So you can see the relationship. So we can basically say it's like an array of 256 items, where each of the items is a value from 0 to 255. So 0, 1, 2, 3, 4, 5, and etc. So now we understand that this enumeration takes 1 byte of memory, and it's very little. Now we can implement this variable. Let's go to our VR hand. Let's see if we can access it. eController hand. And as you can see, it's highlighted here, and we can access it. We don't have any errors. So let's call it hand type. And you may ask me, why don't we use TObjectPointer? Why don't we use something like that? And I have actually an answer for you. First of all, TObjectPointer is used with Unreal Engine classes, but eController hand is a C++ native enumerator, so it's not created by Unreal Engine, and that makes it the first reason not to use TObjectPointer. And the main reason why we don't use it as a pointer, by the way, TObjectPointer, if you recall, is the same as pointer, so I'll just write it as this right now so you could understand it better, takes 8 bytes. Because in 64-bit system, pointer, you remember, it points to an address. An address consists of 8 bytes. Therefore, every pointer, it doesn't matter what type it is, will consist of 8 bytes. And now compare 1 byte against 8 bytes. What's better? Obviously, having a 1 byte is better. So enumerator takes very tiny amount of space. So we don't even care about some operations with this little amount of data. And that's why we can just define it as this. eController hand type. Of course, we want to set it through blueprints, right? We are connecting blueprints to C++. So we want to be able to set this variable in blueprint to tell our blueprint which hand it is. Therefore, I can just copy one of the UPROPERTIES as we did for our classes. And right now, what I see here, hand type. So we can edit our hand type in our level, but do we need it? Actually, no, we just need to edit it through our defaults. So let's use another property. We can use EditDefaultsOnly, which will make this variable editable only in our details panel, in defaults. Then we have blueprint read only. We don't want to edit this variable through blueprint. We want only to read it. And let's put it in another subcategory here. So we use a vertical line and let's call it hand data, like this. So now we can identify our hand. Before we test it, we need to implement another little thing. Let's go in our Unreal Engine and in our VR pawn. If we hover over our skeletal mesh, we'll see that it's some B mannequin XR. What is this? It's still a skeletal mesh component, but it's a child of skeletal mesh component. It's customly made skeletal mesh component. If you look for B mannequin XR here, you will see that it's a blueprint class. And look at that. Parent class is skeletal mesh component. If we enter this, the only way it differs from skeletal mesh component is that it has this variable right here, B mirror. And if I place this variable in blueprint, you can see that B is emitted. So all Boolean variables has this little convention. They have this B in front of the variable. And this B is emitted by our blueprint. You can see there is no B here, but there is B here. It's just a convention that we'll use throughout this project. Every Boolean will call B and give our own custom name after this B. And how it's used? It's used in our animation blueprint. So here we're reading this variable, we're setting it. Here we're mirroring the animation based on what hand it is. I suppose you know all of it, so I'm not going to go in details. And the same variable we're going to need for our C++ because we will want to mirror our animation for our left hand. Therefore, let's go to our Visual Studio, and in here I'll create another variable. And this variable will be of type Boolean. So I'll write Boolean B mirror animation. I'll give it a better name, and I'll make the same UProperty. Okay, so now you can see that we have our components and we have our variables, and I don't see where components end and where variables start. So what I would suggest is doing, let's make our C++ also look beautiful so we could quickly locate our data. The way you can do it is you can give some comments. For instance, you can do a multi-line comment like this, and you can say components. And here, for instance, you can write hand data. I don't like this approach because this is not that visible. You see, it has a green color. This also has a green color. Sometimes it's not very effective. What I use in my projects, I use pragma regions. It's keywords that we use. So we'll say pragma region, and we can call it components. And here we'll write pragma and region. It's purely decorative thing. You don't need to write it in your own code. It doesn't do anything to the code. It just makes the code more readable. And here I'll say hand data, and the same I'll end region. Now you can compare that readability improves much better. And right now what I'm going to tell you that in C++ there is something called comments. That's how you can comment your code. And the way you do it, you put / and you can write anything you want here. It will be ignored by the compiler, and it's basically a text that you can use to give comment to your code, to document it. And there is also a multi-line comment. The way we do it is that we put a / and we use asterisk. And now you can define a region that will be commented, and you can write the data here. So how can we use it? Have you ever wondered that if you go to your Unreal Engine, you might have already hovered on some of those variables? And what do you see? If you hover here, you can see the description of what you're hovering on. And it says the category of the variable, editing this, blah, blah, blah. It's the description of the variable. We can do the same in Unreal Engine. And how do we do this? On the variable we can create, we can write a comment. We can say hand type defines which hand it is. So I will go ahead right now, compile the code, and we'll see what we did right here, and we'll try to hover over our hand type. Make sure you save the project and compile. So as you can see, everything compiled. Let's go to one of our hands and click on defaults. Let's see. We can see first the subcategory has appeared. Our hand data right here has appeared in our category. And let's hover over our hand type. And as you can see, we got the same description. So whatever we wrote here in the comment on the variable is displayed here if hovered. So that's a cool trick to use when you're working in a team. You want your designers who works through Blueprint to know what this variable does and how it influences the logic. And here you can see, since we marked our variable as EditDefaultsOnly, we can edit it only here in Details panel in class defaults. But if we put our hand inside the level, you will not see this variable. You can see hands, but you cannot see anything else. You cannot manage the hand type. But of course, if we come back to Blueprint, we'll see this variable right here. So let's properly mark everything. For left hand, we need to mirror our animation. That's how our VRTemplate works. And let's go to our right hand. So we need to specifically tell our right hand that it's right. We'll use this right here. And we do not mirror animation. Make sure it's false in your right hand. Okay, great. So now we understand which hand is which. So left hand and right hand have a different variable that tells them what type of the hand you are. Next thing what we are going to do is that let's look at our motion controller. Motion controller works is that it needs specifically to know what motion source it is. Because as you can see in VR pawn, our motion left grip has motion source left grip and right grip has motion source right grip. So they are different. So we need to somehow set those variables, motion source, based on what hand type we have, right? And how we're going to do it. So we need to perform an operation that sets our motion source before our game launches. So if we choose our right hand, our motion controller will immediately change its motion source. And the place we can do it, it's construction script. But we're not going to do it in Blueprint. We're going to do it in C++. So construction script is something that executes before the game starts. So first, we have our constructor, then we have our construction script, and then we have our begin play. But wait, we don't have construction script. How we can make it? It's very good because our actor parent class has something called onConstruction. And you will see that it has a virtual method. It means we can override this method. So we can copy this in here and we can place it in our hand. Let's put it before begin play because construction script is executed before begin play. And we need to mark it as override because we want to add our custom logic. And right now you can see the function is not defined. How to define a function? There is really great way and really quick one. You have to press Ctrl. So make sure you hover over this underlined function name. You will press Ctrl and dot. And here you'll see create definition on construction in VR hand CPP. Let's click on it. And you'll see it will be generated right here automatically for you. So now we need to talk what are functions and what can they do? Because what does this void mean? What is this? We don't understand. So let's talk about it really briefly. I will not take a lot of time. So each function in C++ has a return type, then it has function name, and here it has array of parameters. So it accepts parameters in those parentheses. And that's how function works. Void means void. In English, it means nothing, right? So void means this function does not return anything. Then we have a function name, and then we have parameters. So this onConstruction accepts fTransform. What is transform? It's your variable type called transform in here. But in C++, it's marked fTransform. You can see here, fTransform at the bottom. So I'll not use this variable, of course. So it accepts const fTransform transform. What does const mean? Const says that whatever I pass as a parameter, whatever is marked const, cannot be edited. So I cannot say transform equals to fTransform was something else, right? And look at this, error says no operator matches those operands, const and transform. It's because we cannot change our constant variable. So this ensures that our transform will not be changed. And then we see reference. What is this reference? To show this, I open a regular C++ console application in Visual Studio. So let's say we have a function void that returns basically nothing, and we'll call it add1. And as input parameter, we'll accept number. And we will say a equals a plus 1, right? Or we can rewrite it as a plus equals to 1. And let's here create an integer called L, and we'll assign it to 10. Let's call add1, and we can pass L to this function. Let's try to print our contents of L. What will be your guess? It will be 10 or 11. So let's see. As you can see, the answer is 10. Why? But we added 1. The problem is that once we pass variable L, it's not passed by reference. Therefore, the copy of this variable L is made once we get in this function, and we add 1 to the copy. But we do not change initial variable we pass. But if we pass it by reference, you will see that the value of this variable now will be 11. So now it actually added one. Now our variable L is passed by address. An address means we do not make a copy, but we take the variable itself. We take actual variable. We have an actual instance of L. And by directly changing it in our function, we'll change it directly in here. And this omits copying big amount of data, and you can work with variables directly. So now let's look what will happen if we write const here. This happens. Expression must be a modifiable L value. We'll talk about our values, L values later on, but now all it says is that you cannot modify a constant variable. It's constant. So what we can do, we can only use it to print or use it in calculations. For instance, I want to create another variable b equals a plus 5. So this doesn't make any issues. But again, changing the variable itself makes an issue. So constant prevents us from accidentally changing the variable inside add1 because it will change variable L. So this exact picture is happening right here. We're passing transform by reference because we don't want to make a copy of our transform. We want to influence an actual thing we pass, and constant ensures that we do not change our transform because it will simply influence the variable. Okay, so now our construction returns nothing. And let's go to our definition. So here, first thing we have to do, since it's a real engine function, we have always to write super. I can just copy it here, and I need to pass transform. So don't worry if it's underlined, it's all good, it will be compiled, it's just some Visual Studio issue. So this means we want to go to our parent class, to go to our A actor, and execute its on construction first, before we do some custom code here. If you don't put super here, you might have some problems when you spawn the actor in the game. Okay, great. So now once we understand functions, we can start implementing our code. So let's revise what we have to do. We have to take our motion controller and tell what motion source it should have. And we can do it by knowing what hand type we have. And the place we're going to do it is in construction, before begin play. And the way we're going to do it is we're going to use a switch operator. So we'll write switch, and you'll select the switch right here. You'll click tab, and you can see it automatically generates everything. And we'll pass our hand type. And afterwards, we'll move our cursor anywhere. And you can see everything is automatically generated. I will remove all other types of hand, but not default one. So what happens? Now, once we get in this function, if our hand type is left, we will do this code. If our hand is right, we will do this code. But if there is something else, so for instance, our controller hand is, for instance, HMD, we'll use the default section. So if it's not left or right, we'll get in this code. Great. So what we're going to do, if it's left, we're going to get our motion controller and we're going to dereference it since it's an object pointer. It's still a pointer, and we're going to access its motion source, and we'll tell our Unreal Engine. Then if we have our left, we'll say our motion source is left. If it's right, we can copy this code and say right. Okay, so I compiled my project, and before we test it, I want to do a little but important thing. In the future, we'll be changing some properties in our left hand. And just not to copy everything we changed in our left hand to our right hand, what we're going to do, we're going to our right hand, and instead of having our parent class as VR hand, we're going to have it as BP left hand. But we need to be careful after we did this, because the values from left hand can be copied to right hand. So let's go to class defaults. Our left hand is this, and our right hand is having its mirror animation set to true. So it copied the value from left hand. So make sure you will take this to false for now. So you'll have this picture right here. So now let's look if our construction script here has propagated to blueprints. In our left hand, our motion controller now has source left. Let's look at our right hand and make sure you compile, you save. Well, we still see the left, but construction script has actually already made it right. It's only shown in the blueprint that it is left. And how do we verify this? First of all, I want to add a call to parent function. Since we have assigned our left hand as parent to right, I want to make a call to parent function. So essentially in right hand, we are doing this. We're calling our super. So whatever code we will write in our left hand will be also executed on right. So let's go ahead and get our motion controller, get motion source, and let's go ahead and print it just to verify that we are correct. Now, let's go ahead and put our left hand and right hand inside our level. And let's simulate our game. And here we have the proof. Our right hand was initialized to right. So, despite of right hand having this variable right now set up on left, our construction script may not right away set it to right. But also construction script is triggered when the object is spawned in the level. So that's why when object is spawned in the level, this code is triggered and it sets our motion source to write, as you can see right here. I'm going to delete this print function right here. We do not need it right now. I'm going to hit compile and save. Now, what do we need to think about? What if user accidentally sets the wrong type, for instance, to right shoulder? Then we'll have a problem because in here, this will not be triggered. So we need to somehow let a user know that he has mistakenly set the eController hand. And the way we're going to do it, I'll set it to left back. And the way we're going to do it is we'll go to our begin play. And what we're going to do, we're going to check if our hand type does not equal to eController hand left and hand type does not equal to eController hand right. Like this. We're telling again, hand type does not equal to left and hand type does not equal to right. So if we have neither of those, we'll execute custom logic. And what we're going to do, we're going to learn how to print a debug message on the screen. So we're going to use gEngine. We're using the engine and the method is called AddOnScreenDebugMessage. And yes, gEngine is a pointer, therefore we have to dereference it. And since it's a pointer, we're not sure if it's valid. So we always need to check if the pointer we're using is valid. Therefore, we'll put it in if statement like this. And just to recall why I'm not putting motion controller in if statement in here, because I'm sure the construction script is executed after our constructor. And in constructor, we initialize the motion controller. So I'm sure it's not empty. That's why I can dismiss this if statement right here. Okay, let's back to gEngine. Let's see what we have control over. We have key, time to display, display color, debug message, and look what we have else. We have newer on top, and we can even change the scale of the text. Because look, in our default print statement, we don't have access to those parameters. We cannot change scale of the text, but in C++ we can. And that's one of the biggest advantages of C++. You have the full control over what you're doing. So you have some hidden features and some hidden optimizations. So let's see our first parameter. It's key. What is key? Every message has a key. If two messages have the same message and they have the same key, they are displayed only once. So if you are displaying message every tick with the same message and same key, they will be displayed only once. But to avoid this, we'll use -1. Put -1 here. Doesn't matter what key, doesn't matter what debug message, it will be displayed one on top of each other. Now, time to display. So please right now, listen carefully. I'm going to explain you a really important thing. As you can see, it accepts float right here. It says float. But what if we write just 4? So we want to display for 4 seconds. Let's do it. And let's see what 4 is. 4 is an integer. But we do not have any error. Why is that? Because Unreal Engine, under the hood, makes conversion from integer to float. And this takes your effectiveness. If you're trying to make your code effective, you don't want to put integer here. We want to put float right away. So what do we have to do? We have to put .f. It will convert this number to a float. And as you can see here, now we are passing a float. But what about decimal numbers? If, for instance, 4.5, if you hover over it, there is no f in the end, you will have double. And double is the same float, but it takes bigger space. To quickly go through it, double takes 8 bytes. Float takes 4 bytes. So when you're passing double in here, it's double, it converts it to float. So it cuts double in half and leaves only 4 bytes right here. Meaning that if you have incredibly large number here, it will cut it in half. This also takes some time because we're passing double. An engine takes some time to convert double to float, and we want to omit it. That's why we need to make sure we pass float variables, and we're using float variables. Float variables are very cheap. They're only 4 bytes. So we need to add f2. So you can see right now it's float. So again, what is the convention? When we want the whole number and we want it to be float, we just add .f. When we want a fraction, when we want a decimal, we just add our decimal part and add f in the end right here. Okay, let's look what is next. Next, we have fcolor. So the way we do fcolor, we write fcolor. Fcolor, as you can see, if you click on it, it's our struct. Struct is basically the same as class, but all of its variables are public by default, so they're accessible anywhere. And the way we access variables from struct is by member selection operator, like this. And as you can see, we have a lot of colors. And look at that, we have even make random color. Can you do it in Blueprint? No, you cannot do random color. But in C++, you can make random color. And now every message printed by our print string will generate message with random color. It will improve readability. but it's our error message, so we'll have it in red. Now here we have fstring debug message. You can see it's using a reference operator because fstring takes some data, so we want to pass it by reference, not to make a copy of it, and we use const. That ensures that this variable is not edited when going through our AddOnScreenDebugMessage. So I'll use fstring, I'll construct this, and I will tell wrong hand type. But wrong hand type is very vague, right? We do not know which class has wrong hand type, so we need user to know on which class we have made a mistake. And to do this, it will be a little bit more complex, but I'll explain about this concept in future lectures. But what we'll have to do, we'll have to use printf, and we'll have to print text, which will have wrong hand type, and now we can specify class. So we'll write class %s. %s means s will be replaced by a string. So after we put comma, and now we have to specify the string that this %s will be replaced by. And what do we need to do? We need to print the name of our class. And there is a very good function our class has. It's called getClass. Let's look at what it returns. It returns a pointer to a class. So now we have a pointer to our own AVR hand. And what we need to do with pointer, we first need to dereference it. And how are we sure that this class will return us a valid pointer? Because we are already calling this function in a valid class. That's why it 100% returns us a class. And now we call a function called getName. And we need to add some more parentheses in here to make sure we close them correctly. Now we have a valid debug message. So make sure you save our code and let's go ahead and compile it. And here we have this weird error. Now let's go deeper of why we got an error, because here we don't have any errors. It happens because look at what our printf accepts. Usually when we're printing some string, printf, it accepts constant char reference. So let me actually open a console application. I'll tell you here. So basically, if you're familiar, there is a way to set up a string, A, B, C, D, right? So string is actually a specifically made class by C++ developers. The more low-level way to do a string is making constant char pointer A equals to some number. So this is the way to specify our string. In printf, it's the same, because printf accepts constant char, and as you can see here, it accepts a reference of char. So now this %s converts the return from getName, it converts string to character. It converts it to a pointer, like this. So now we have to dereference our pointer in order to get the value. So what do we have to do? Dereference it. So now we are getting the value under this character array. So again, we returned fstring. It converted to pointer to char array because of this %s, and we dereferenced it to get the value. So now if we go ahead and compile it, you'll see that we'll have a successful compilation. And now let's go ahead and change the variable in our left hand, for instance, hand data to any hand. And let's put our hand in level. So now its begin play will trigger, and you'll see there will be a debug message right here. So now class BP left hand C, wrong hand type. But if we put it to the right hand type, for instance, our left hand is left, we try to launch the game again, we will not see any errors. Everything is okay. Okay, and last thing I want to do, as we can see, our hand has those variables added defaults only. I don't know why I don't like it, because we can replace them by some other variables. So what I would essentially do is that I would go to components and change those variables to visible anywhere. Like this. It will allow us to also edit it through defaults panel only and not being able to edit it through our engine. So I will go ahead and compile it right now again. Make sure everything is saved. And I got an Unreal Engine crash, and that's totally okay. It sometimes happens during compiling. Don't worry, it's not the issue in your code. It's just the way Unreal Engine patches the compilation. So what we have to do, press on this send and close. We'll have to go back to editor, and not to launch Unreal Engine from scratch, we're just going to press Ctrl F5. It will build our solution and relaunch the editor. As you can see, build is successful. I don't have any errors, and my Unreal Engine is going to start right now. So my Unreal Engine has restarted. And let's click on our instance of left hand. And as you can see, we can no longer change its components, and we'll still have access to our variables inside our editor. So you can see I still can change all the variables right here. And also in our class defaults, we don't see the same picture as we saw in our editor before. This was the last thing I wanted to talk about today. We finally set up our hands for using with motion controller. We can already use them. And in the next lecture, we'll properly set up our hands using blueprints. We'll set up animations and we'll start implementing our grabbing system. So see you in the next part.